say anything. Okay, so yesterday we left off with, I think if I remember right, we were on stretch and shrink, right? Did we get to that part? And I talked about vertical, and then I said something about horizontal. Horizontal actually isn't until section 2. So I'm actually going to skip the horizontal for now, but even though it does the same type of thing. But the vertical, stretch, and shrink, did we go through any samples for that? Yeah. We did? We got all the way through there? Okay, just to kind of, just so that I know where we're at. Kind of the last little thing to clean it up now is now I'm going to give you some that have multiple things happening. Not just one or two things, maybe 3 or 4 things that could happen in a problem. So, Amanda, give me a parent. Which parent do you want to use? Linear? Okay. So, if I use the linear parent, that is my problem. I have negative 3/4 x plus 7. Now, if it's a line, you guys in Algebra 1, you guys graph lines before. Most of you know how to do that. You wouldn't have to necessarily do it with the transformations. A lot of you would probably do what first? Anybody know how to graph that? No. What's so significant about the 7?
That's where you start.
That's where I start. What do you mean where I start? The what? The Y. Right. It's the Y-intercept. That's what the 7 is. Also, if you think about yesterday when we talked about it starting at the origin, we said up 7, didn't we? That's outside the grouping symbol, right? So therefore, that's going to move it up 7. What does the 3/4 do? Somebody said it. Start with an S and then a lope. And that's the slope. However, on this particular concept, 3/4 would be a vertical shrink. Okay, that's what it would be because of the fact that it's less than or it's in between 0 and 1. So it's going to be squished down a little bit. What's the negative do? According to what we had yesterday, the negative on the outside flips it over the x-axis, or basically instead of going up, it goes down. So when you graph these in Algebra 1, you probably didn't think of them that way. But as a linear concept, that's what's happening. So for me to describe what changed, it went up 7. That's the first thing that happened. And when I do this, just so that you guys know, what I might do is I might put a box around the parent, and then everything else is a transformation. If you put a box around the parent, everything else is a transformation. So we actually have 3 different transformations that happen. Most people forget about the negative sign. That's the big one that most people forget about. They don't include it. They just think it's part of the number in the front with the multiplication. The up 7 dealt with this part back here. Then the 3/4 we talked about. That is going to be a vertical shrink. Why was it a vertical shrink? I've already said it, but why was it a vertical shrink? It's less than 1, but greater than 0. And then the third and final one is the negative sign. What's the negative sign do? Reflection over which axis? X. Okay? Now, once I asked you to describe it, you just described it. Yeah, I knew what the parent was because I asked Amanda to give me a parent. She did. She gave me linear. So that's why we knew it was that. If they ask you what kind of parent it is or which family it belongs to, you would write linear. How do you graph that? If it's a linear, you guys probably spent, how many weeks did you guys spend graphing lines in Algebra 1? Quite a few? You probably did. Does anybody remember how? You guys already said something about a Y-intercept. Nobody wants to say? Alexis, to you?
Is there y equals mx plus b?
Yeah. So what is the b in this case, as you guys were already saying, the 7 goes with the y-intercept. So when I draw this thing, I didn't really leave myself enough room. Shame on me. I'm going to go up 1, 2, 3, 4, 5, 6, 7, make dot. How am I going to get a second dot? Down 3, over to the right 4. 1, 2, 3, 4. 1, 2, 3, over 4, makes another dot. Now what? Draw a line. Yeah, connect the dots. La, 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 la. All right. Now, the parent for that thing was this guy. That's what the parent was. So think about the parent, the blue one, and I know it's kind of hard to see the blue up there. But when you think of the parent, think about how it reflected over the x-axis. So instead of on the right-hand side where it went up, it goes down. And on the left, it went down, it goes up. So it reflected. So instead of this, it went like this. That's what happened. And then you picked it up, you grabbed it, you moved it up 3, and it got squattier. Even though it looks like I didn't do a very good job spacing it. But when you draw that one, that would have been hopefully a lot better than mine, where it should not have been steeper than the original one. It should have been flatter. Because it would have been down 3 over, so it would have been stretched, it would have been shrunk a little bit. Okay? How many different transformations did I do there? 3. Okay, is that uncommon to have 3 transformations? Absolutely not. Sometimes there might only be 1, sometimes there might be up to 4. You won't have any more than 4, but that's what it means by a combination of them. Now, let's do a different parent. PD, give me a parent. Other than linear. Quadratic. Okay. Let's see, this is where I get to learn your guys' names a little bit better. Because I know absolutely 0 of you. That's not true, I know some of you. I'm getting there. Sam, give me a number. 7. Oh, yeah. Horrible at names. Hope. Give me another number.
2.
2. And Vitaly, give me one more. 3. Okay, so how many transformations do I have on this problem? Anybody know? Mr. Silva, do you know? 2? Okay, good guess. More than 2, though. How many do we have? 4? Nope. We have 3. Here's what happens. Okay, watch what's going to happen. I'm going to put a box around the parent, and this one's kind of tricky because of the fact that I inserted a grouping symbol. When I asked Mr. Peterson for a parent and he said quadratic, the reason why this is squared up here is because he said quadratic. That's why I put the 2 there. And the x is the other one that attaches to. Those 2 things are the parents. The other pieces are not part of the parent. Okay? It's kind of like if you've ever watched Sesame Street before when you were a kid, if they still have it on, and I know they do on HBO now, if you have HBO. Okay? Have you ever heard of that thing like one of these things is not like the other? One of these things just isn't the same. So then you say, what's different? If you take the parent out of the question, what's different? That's what they're asking. So, when I asked those people for some numbers, Chandler, did you know what's the 7 so significant about? Do you remember? Let me ask you a different question. With the 7, is the 7 being multiplied or added? Multiplied. So as soon as you see that it's multiplied, then it has to be either what or what?
Stretch or shrink.
Very good. Is it a stretch or is it a shrink?
Stretch.
Yeah, why?
Because it's greater than 1.
Absolutely. Nice job. So it's a vertical stretch by 7. Okay, that's what it is. Which means what? That means when I draw the normal parabola, it's going to be up here. It's going to be skinnier. Okay? Then, Taylor, what does the 2 on the inside of a grouping symbol do? Let me ask you this question. I'm going to do the same thing I did for Chandler. Is the 2 being added or subtracted or multiplied? Added to the x. Don't worry about the 7. 7's its own animal. Okay? The 2 is being added. So as soon as you say added, then we are not stretching and shrinking anymore. We're doing one of the first ones. And what is that? What happened when it was inside the grouping symbol? Where did it go? Can you find it? Good. How far? 2. Right, because that's the number. That's going left 2. Good job, Taylor. So proud of you. Sarah? Not here. I haven't done attendance yet. Tamara? Is the 3 being added, subtracted, or multiplied? Added. Inside or outside? Outside. So what does the outside of it do when it's added? It moves. Which way does it move? How far? Nice. Okay. We're going up 3. So at this particular thing, have I accounted for every different transformation that took place in there? Just so that you guys are aware of it, the only other transformation I could have inserted in there would have been a negative sign symbol. I did not put a reflection in this problem. That's the only other one that I could not have. Okay, so the highest you're ever going to have is 4 different transformations. It's the very highest you could ever have. And then it could always work all the way down to only having 1. Okay, so for this particular one, I only put 3 in there. And it's actually not even me. You guys did the problem. Okay, you guys are the ones who made it. Now, how do you graph it without a graphing calculator? Some of you will be able to take your graphing calculators and you'll type it in exactly the way it looks and hit graph and you'll see what it did. Awesome. Some of you that don't have a graphing calculator yet, that's okay. I know they're coming. Okay? But what do you do in order to be accurate? One of the things that this book has in there is they also want you to insert numbers, get some ordered pairs, and plot the points. Can you guys insert numbers for X and get out answers and plot points? Is that something that you guys remember how to do from Algebra 1? Or even a little bit in geometry? You put a number in for X, figure it out, and then that's the Y coordinate, and then you plot them, connect the dots. Okay. So if I was going to graph that, again, the parent for what Mr. Peterson had said, the parent was this nice parabola right here, or as best as I can draw it. Now again, how did I get that parent? I could have inserted numbers. If I put in 1, 1 squared is 1. Put in 2, 2 squared is 4. 3, 3 squared is 9. And I could have put those ordered pairs on the right side. The -1 squared is 1. -2 squared is 4. And I could have plotted those ordered pairs and connected the dots. With what you've told me what to do, you told me to pick this thing up, move left 2, 1, 2, go up 3, 1, 2, 3. That's where that new bottom point is going to be. I know it's kind of hard to see. Should I not use orange? Or can you guys see that? Don't use orange? Okay. Yellow would be even worse. How about red? Can we see red? Okay. So that's where the new bottom is going to be. Now, is this graph going to get skinnier or wider? Skinnier. Now, just so that you guys know what you would do for something like this, if you wanted to get even more accurate, is since I went over 2 and up 3, and that's the bottom point, or when we get to that later on, that's going to be called the vertex. If I put -1 into my problem, what number do I get out? What's -1 plus 2? 1. What's 1 squared? 1. What's 1 times 7? 7 plus 3? 10. So that means this. When I put -1 in, I should get a 10 out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be way up here. Because, and hopefully you guys know anything about symmetry, if I do something to the right, it's also going to be the same on the left. So therefore, at this point, if I were to plug it in, I would have also got 10. And this thing's going to go a lot skinnier than the other one, isn't it? What do you guys think? Are you guys capable of sketching graphs as best you can? How about describing the transformations? Are you guys okay with that? Use your notes. Use those things. If it's outside adding, that's up and down. Inside adding and subtracting, that's left and right. Outside multiplying, that's either stretch or shrink, depending on if it's a big number or a fraction. And don't forget the negatives are reflections. We did not have that in this one, but we had it in the linear one that Amanda had. Okay? Are you guys okay with this? Do you think? All right. Now, you don't have your books yet, but that's okay because I'm going to show you. But here's what the directions have you doing. It says, graph the function and its parent function, then describe the transformation. Now look at that problem and tell me we did that. Is that exactly what we did? Did we draw the parent? That was the black one up there. Did we draw the new one? That was the red one up there. And we listed all the different transformations. That's the answer. That's what they would want you to do. The second set, graph the function and its parent, then describe the transformation. Same thing. Third set, use a graphing calculator to graph the function and its parent, then describe the transformations. So if you have a graphing calculator, you're absolutely more than welcome to use it. I'm not actually going to go through how to type them in just yet because not everybody has them. If you've already used one before and know how to type one in, be my guest. It's pretty easy. First thing that you have to do, Taylor, is you have to turn it on. Are you okay with how to turn it on? On? Did you charge it? Oh yeah, you did. Then up here in this corner or up here on these buttons, it says y equals. Y equals is the same as f of x or g of x or whatever. So if I hit y equals, now I get to type in the equation. And I type that in exactly the way that looks up there. 7 parentheses x. The x button is right next to the alpha button, just so that you guys are aware of that. Okay? It's right here. I don't know where it is on one of those. We'll have to look again. Plus 2. Close it. Squared. Plus 3. So now if Taylor hits graph, Taylor's going to see one eventually because it takes a little bit longer because it's a color screen one. And if Taylor would show everybody, because she's not going to because she just wants to keep it for herself. But that graph, is that similar to the one that I have up there? Yeah. Is that one more accurate than mine? Yeah. Way more accurate than a homemade hand graph, right? So just so that you are aware of that. And we'll go through that a little bit more as everybody else gets it. Then they got another one that says identify and correct the error, what they do wrong. And then again, identify the function family and describe the domain and range. Okay, that's something that we haven't talked about yet. Domain and range. Domain, just so that you guys are aware of it, it's the x values that work. Okay, that's what domain refers to. It's the x values that work. The range is the y values that you get out. Okay, that's what the domain and range is. Domain is the numbers you insert or input. So remember on that last one where I just said -1 and I inserted it and got 10 out? Domain on that one, or one of the numbers, would be -1 because I put it in. And the range would be 10, or part of the range would be the number 10 because that's what I got when I put it in. Okay? On constant equations, so the ones that just have a number, the domain is all real numbers because it doesn't really matter. It goes everywhere from left to right. That's what the x values are. The range for the constant ones are whatever number that you're on, because it does not have multiple answers. Okay? Domain is everything that works from left to right on the graph. Range is everything that works from floor to ceiling on the graph. So on a constant equation, domain, everything works, so you would write all real numbers. And the range is whatever number it was with the problem. For the linear ones, like the one that Amanda asked us to do, or she picked for the family, the domain for those is all real numbers because that goes on forever to the left and to the right. So is the range because that goes forever through the floor and the ceiling. So if you have a linear family, your domain and range are the same. It's all real numbers for both. If you have an absolute value equation, you can put in every real number. You're not going to get every real number out, though. And here's what I mean. When you have the V's, like we had yesterday, boom, boom, okay? If that was going on this axis like this, and that's kind of similar to the parent, no matter what, I can put in x's from left to right. That's all real numbers. Everything's going to work. But the range is from ceiling or floor to ceiling. It does not go all the way down, does it? It bounces. At what number does it stop at or start at? 0. So for something like this, when you talk about domain and range, domain would be all real numbers. Anybody know how to write all real numbers besides the words? Besides writing all real numbers? All real numbers has a symbol. If you haven't figured this out yet, and you will from me, us mathematicians do not like to write. So we use symbols for everything. That fancy looking R refers to all real numbers. Another way that it's also written is this: negative infinity to positive infinity with parentheses on the ends of it. That is what we call interval notation. Okay? Interval notation is something that we use it heavily in college algebra, and the algebras in high school are just starting to kind of get to it. Last book never had it. This one's starting to. You guys used to see something like this. Negative infinity is less than x is less than positive infinity. That was one of the things that you guys used to see it as. Okay, or something like that, like it go, or not less than, greater than. Or not greater than. It is less than. Never mind. Okay? That's how you used to see it on, like, mainly is that it's going on forever from left to right. For the range, you probably saw this as y is greater than or equal to 0. That's how you saw it in Algebra 1, typically. But when you get to upper level maths, they're going to have it in interval notation. Because it was equal to, we use a bracket. And we started at the 0 and we went to infinity. Infinity will always be a parenthesis. Bracket means it can equal it. Parentheses means it cannot. Can you ever equal infinity? Is infinity a number? No. Infinity is a concept. It just means that we know numbers continue to go on forever. We're just not going to write them all down. Those are acceptable answers for the ranges. Okay? What about the quadratic ones? What about the quadratic family? What numbers work for x? Take a guess. Huh? All of them, right. This does not have any domain restrictions. Okay? This one is good to go. What about the range, though? Does it go all the way to the floor? No. Where does it start? 0, and then goes where? Up to infinity. Or y is greater than or equal to 0. How about the one that I shifted? The one that we did where it had 7 and then x plus 2 and then plus 3. Does that have 0 as the range now? No. Why doesn't it have 0 as the range? Because that's not the bottom. The bottom would have been at 3. So then we would have went 3 to infinity. Or greater than 3. Alright? So that's what it means by domain and range as far as what values work. Notice what the domain is for every single one. Every single one of these families have the domain of all real numbers. Okay? What do you guys think? We'll see. Alright, so on here, we're starting on page 8 to 10. We're 9 to 42, multiples of 3. We better figure that out because some of you don't know what that means. 46 and 51. So, Petey, do you know what multiples of 3 is? Yeah. So that means you start at 1, then 4, 7, 10, right? No. Good. What number do you start at? 9. And then go to what? Huh? 12. Then 15. Then 18. Then 29. Okay, so just so that you guys know, I have had that. That's the reason why I needed to go through that. In the past, I've had people who start at like 1 and then go to 4 and 7. Those are not multiples of 3. They just count them by 3. Okay? Don't do that to them.